Let us now discuss some common IC regulator circuits, IC regulators that are available in the market, popularly available in the market. One of them, of course, we just now saw in the data sheet, which is 78XX series. Let us see how we will incorporate them in the circuit. Consider that we have 230 volt mains. This is an AC voltage, and we will use a transformer, and the output of the transformer is a step down transformer, so that we get output 5 volts. Then the step down transformer is connected to a rectifier circuit like this, and the output of the rectifier is connected to a capacitor filter, and the output of the capacitor filter is connected to a 3-terminal regulator like this, and the output, this is the load R0. So let us say if I use 7805, which means a 5 volt regulator. This has the in terminal, out terminal, and the common terminal, and here you will have 5 volts coming at the output of 7805. You should have a minimum differential of delta VIO of at least 3 volts, should be greater than 3 volt, which means that here the voltage should be greater than 8 volts. So when you are designing the turns ratio, you should see that at least under VI min condition, you should get 8 volts at least. So that then only this 3-terminal regulator will provide regulated output. Let us say now that you need a multi-output power supply. Let's say you need a 5 volts, and you need another 15 volts, which is isolated. You don't need to put another transformer. You can wind one more secondary on the existing transformer. So on the same transformer, you have one more secondary, have one more rectifier diode bridge on the secondary side. Only this turns ratio and this turns ratio will be different. And put a capacitance, and output of the capacitance, put a 3-terminal regulator, let's say 7815, and connect it to the load. You have the in, out, common. So if you need 15 volts here, you will need a minimum differential of at least 3 volts, and at least 18 volts is needed at this point. So accordingly, you can adjust the turns ratio between the primary and the secondary. Now this is a way you will get a multiple output power supply. Now let us say that we would like to have a dual power supply with a common ground plus 5 and minus 5 volts. How would you go about doing that? The input side remains the same. You will have a transformer with multiple secondary, rectifier, and the capacitors. Make some modifications here on the output side. Let me remove this and then put a 7805. I'll set this to 8 volts like this. This will be 5 volts, which means I will replace this by 7805. So both these are giving 5 volt isolated outputs, no common ground. So what you do, you short the minus of this to the plus of this, and indicate that as the ground or the zero potential. Now all your further circuits should consider this as the zero potential or the circuit ground. Then with respect to this zero potential, with respect to this node, this point will be at plus 5 volts. And with respect to this zero ground, this point will be minus 5 volts. So this way, this power supply together shown like this acts like a dual positive negative power supply. Let us discuss another example, this time an example of LM317, where LM317 is a high power variable output voltage regulator. You can set to any output voltage, just like LM723 also. Both LM723 and 317 are variable output voltage regulators. I will take LM137 as an example. Another sister of LM317 is LM350, which is a much higher power regulator. So let us construct the regulator structure. I have an input unregulated voltage, and that is connected to the 3 pin regulator, the in pin, the adjust pin, out pin, and output connected to the load or not, like this. Now the adjust pin is brought down, connect a resistor here like this, and from here you connect another resistor in this fashion. Name this as R1, name this as R2. How do we choose R1 and R2? Observe that, look into the data sheet, there is a fixed voltage difference between the out and the adjust pin, out being more positive than the adjust, and that is 1.25 volts for the 317 regulator and also 350. Now if this is V0, then we can say V0 equal to, if you look at this network, 1.25 by R1 is the current that flows through R1. This is a high input impedance pin, therefore all the current flows in through R2. So you will have 1.25 by R1, current flowing through R2 into R2 will be the voltage drop across R2, plus 1.25 will be V0. So therefore V0 is equal to 1.25 into 1 plus R2 by R1. So this is the voltage relationship, and then accordingly you can choose the value of R1 and R2. If you make R2 adjustable like this, you will see that R2 in this equation is a variable, and you can get an output voltage setting as different values for different values of R2. Now, apart from this, there are few other protection components that are needed to complete the circuit. First of all, of course, we need to put a 0.1 to 1 microfarad capacitor here. This is just in case to be to make sure that there is a decoupling at the input side and there is sinking capability also. Likewise, in the output side also you put a capacitor 10 to 20 microfarads. Then important, you have to put a protection diode like this. The protection diode doesn't come into operation normally, but this comes into operation during switch off conditions. Let's say you switch on. When you switch on, there is some voltage here, and then there is a drop across this, and then there is a voltage at the V0, some set value. Now, when you switch off this, let us say the input goes to 0 quickly and the output has not yet discharged, which means the out terminal will have some finite positive voltage, in terminal will be 0, and then the input to output differential voltage will be negative, which will damage the IC. Therefore, if you put a diode like this, whenever the output terminal is more positive than the input terminal, the diode will conduct and sink into the capacitance, thereby protect the IC. So this is an important protection diode that you need to put so that the input output differential voltage doesn't go negative. Another important component we can have is add a capacitance here, 10 microfarad. This will act like a filter and stabilize the potential here. Once it stabilizes the potential here, output regulation is much better. However, you will see that when you switch off, there is no discharge path for this 10 microfarad capacitance. It has to be through R2 or it has to be through R1 and the output capacitor or the input capacitor. This can be a long time constant. In order to speed up, we can put a diode like this, which in this way this capacitor can directly go and sink into the output or sink into the input. So these are some of these protection features you add, and this will make it a workable circuit.